Hi. So this is the masterreliability.com website, and you're going to find a bunch of tools that will help you in your manufacturing journey. If we go to frame D, we can see some case studies here. And this is really about machine forensics. In this, we're going to go over structural breakdowns. In this case, it's a gearbox. And you can see how we went over the background. And then we discussed the different fingerprints. So a fingerprint is a characteristic signature of a particular issue. So in this case, fingerprints, gearbox crippled by domino failures, infant mortality, that means it failed early on. It is associated with the following fingerprints: a high frequency whine, broadband vibration, fast heat climb, lubrication clues, and visual inspection signs are early misalignment at the coupling interface, showing discoloration around the seals, gear teeth exhibiting pitting, cracking, and chipping, and noticeable shaft wobble. The fracture surface appeared rough and dark and gray, so you can see the sludge around it. Now, this is a simulated AI image, but this basically shows you the pitting, which are these indentations right here, the sludge, which is this dark formation here. And so you can really see what's going on. Now we can look at the FAMICA, which is a failure mode effect criticality analysis, and it has an RPN, which is a risk priority number of 420. That is very high. That is going to cause a huge break. It is going to cascade, and then it's going to cause the entire equipment and the line to go down. Severity of 10, it means it's huge risk. It has a huge impact. The occurrence, it is pretty high, and the detection is high, which means that we can detect it early on. Now, what are we looking at? This is the life cycle here. We have a defect is introduced. That defect causes a stress concentration, so the concentration of stress in that particular defect region and area. It initiates a crack, and then once the crack is initiated, as more stress is added, the crack propagates. This causes a brittle fracture and collateral damage. So why does a brittle fracture occur? Well, we see internal flaws, so voids, inclusions, or porosity acts as a stress concentrator. So this can happen when it was formed. So let's say that we have a part that is made through a gel die, which means that we're going to die cast the part from a sand like material, and inside that sand like material is actually metal that is put into a cast. That cast is compressed, and then inside that, it then goes to the furnace and it goes through the entire process of formation. The problem is that, let's say some of that sand type material has a void or inclusion, which is particularly a dirty, contaminated contamination that's not supposed to be in that, and that will act as a stressor because it's not formed properly. So we have improper heat treatment, surface imperfection, design flaws, assembly errors, right? So that we might, during installation at the factory or during the acceptance, we may have a flaw because let's say that we didn't align the part properly, which caused a misalignment at the beginning, and then that misalignment escalated and caused uh, abnormal wear on the part. And then material contaminations, which causes sludge. So let's say if it's a case packer and that case packer is around a lot of contamination due to the cardboard, you're going to get that cardboard dust inside bearings where you have your lubrication. That lubrication then causes sludge, and you have this internal mess. So it all adds up. And then what's the consequences? So if you look at here, the consequences, we have a manufacturing defect, stress accumulation, excessive heat, lubrication breakdown, crack initiation and propagation, brittle fracture, collateral damage, unplanned downtime, and the total cost of not paying attention early, of having untrained operators, is a whopping $85,000 a pop, which is quite a bit. So if we used Frame D, we would not have missed the fracture. We would know what to do, and we would know our operators would be well trained to identify and understand what tasks they need to do and then when to escalate. This provides enhanced quality control in manufacturing, and we are able to stop it before it really has a start in causing an unplanned downtime event. So that's really what machine forensic is. It's understanding the core components that cause premature failure and what we can do about it, and then the tasks involved to stop it. My website is jam packed full of these case studies, as well as other tools you can see here. You will need to become a member to use some of these tools. But membership is free, so please join, and you will get access to CI applications such as Conditional Monitoring Library. Oh, this is a great one. It is made with a script that will really give you quite a bit of information for what tests to do and when to do them. So I welcome you to this group, and I look forward to hearing from you. If you want, drop me a line and look over the blog as well, because the blog has a lot of articles as well as quick wins. So a quick win is using a Nord-Lock washer. So when you're in manufacturing, there's parts of equipment that you have to get to secure, because they're prone to vibration, and an abnormal vibration occurs when something is not set up properly. If we use a Nord-Lock, we would prevent that, because Nord-Locks are very secure and keep the machine in place. So they're less likely to have that problem even under an abnormal vibration environment. So there is a lot of things here. Welcome for you to look over, and I hope that you do. And again, drop me a line if you have any questions. Thank you.